everyone, welcome to another maths video by Maths with Sarah. So today we're going to be taking a look at this question from an Edexcel November 2018 higher paper. It's paper 2, so a calculator is available to you, but to be honest, I'm not sure you'll necessarily need it for this question. So this is question 18, definitely comes from the back of the paper, so we're looking at quite a tough question here. As with all of these videos, I would encourage you to pause the video at any time and try and see if you can work through either copy what I've done or see if you can then take it further using what I've done so far as like my hints. And also just at the start to have a look at what you can work out by yourself, because you never know, you can actually, like, this is a good 4-mark question, and it's always good if you can pick up a few marks from somewhere, even if you can't get to the end answer. So let's take a look. So we've got a straight line L1 passes through 2 points with the coordinates 4, 6 and 12, 2. Then we've got the straight line L2 passes through the origin and has a gradient of -3. We've been told that the lines L1 and L2 intersect at point P, and then we've been asked to find the coordinates of point P. Okay. So quite a lot going on here. We've got to kind of recall all the knowledge that we've got about how to work out the equations of lines, knowing the coordinates, or lines where we've got some information and we've then got to find out the rest. So the first thing I'm going to do is just literally write on that the origin is 0.00. I know that might seem like a strange thing, but it's always good to have a reminder that we have got a coordinate here, even though we haven't got one written out as such. So again, just a little reminder, the origin is the 0.00. I'm then going to have a go at kind of drawing a diagram. You'll notice I've already kind of got some axes set up on here. I'm going to draw a diagram of what these two lines look like, and then I'm going to be able to use that to kind of help me with what I know so far. So I'm going to start off, I'm going to draw a line. It passes through the points 12, 2, which is going to be somewhere over here, and 4, 6, which is probably going to be somewhere over here. So I'm going to draw quite a shallow line, but it doesn't really matter what it looks like because we don't really have any information about this at the moment. I'm then going to draw this other line, which is L2, which passes through the origin and has a gradient of -3. So again, not that we know very much, but all we do really know is that it goes through the origin. So I'm going to pop this line going across here. And now I'm going to label what I know so far. So I know that this point, a point roughly here, again, it doesn't have to be accurate, but it does just have to be able to give you an idea of how these points all interlink. I'm going to call this point here 12, 2. I'm going to call this point here 4, 6. If you notice, I've very slightly drawn it to scale, you know, like this is kind of 4, 8, 12, sort of vaguely works. It's about 3 times higher than this one, you know, but it doesn't have to be exactly accurate. We've then got this point here, which is passing through 0, 0, which is the coordinate that we've got for L2. And this crossing point here is going to be point P. Obviously, we don't know the coordinates of that yet, and that is the task for this question, is to find out what the coordinates are. While I'm at this point, I'm also just going to label that this is my line L1 and this is line L2 so that I don't get confused further down the line. So we're going to start by finding the equations of each of these lines. So again, remember, feel free to stop the video here or pause the video here, see if you can find the equations of the lines. That definitely gets you a large chunk of the marks for this, is finding the equations of both of the lines. Yeah. So if you're struggling with that, the line L2 is the easier equation to find. So I'd recommend starting with that one, and then we'll work on line 1. So for L2, we know that it passes through the origin and it has a gradient of -3. So if we go back to the equation that you've probably got ingrained in your brain at the moment, we've got the line y is equal to mx plus c. This is like our standard line, isn't it? We can fill in the gaps, but this is kind of always the starting point. So the gradient is m, so we can substitute in a gradient of -3. We can substitute in an x value, because remember, a coordinate always gives us an x and a y value. Substitute in an x value of 0 and a y value of 0. Obviously, for the plus c. what you've hopefully realised is that we didn't actually need to do that, but obviously it's still good practice. And we've ended up with -3 times 0, which is 0, so we just end up with 0 equals 0, so our C value is 0, which we could have realised because it's going through the origin, but just for clarity, I've gone through all the steps. So L2, we've already got the gradient, we know that we've got a C value of 0, so we can write down that the equation of this line is y is equal to -3x. If you want to, you can write +0 just as a reminder, but I'm not going to write it just for clarity here. Okay, so that was the slightly easier line. L2 is an easier line to find the equation of. Let's now look at L1. So we have been given 2 coordinates. Remember, each of these coordinates have an x value and a y value. If we look at our y equals mx plus c, we've got 2 unknowns at the moment. So we can't find it out straight away. We're going to start by finding out what our m value is. And to find out the gradients, again, there's multiple different ways of doing it. Some people say y's over run, some people say difference in y's over difference in x's. As long as you're consistent and you get the right answer, it doesn't matter what method you use. So I'm going to go with the difference in the y's, subtract the difference in the, divided by the difference in the x's. So to do that, I'm going to start with this coordinate. So I'm going to circle this coordinate so I know that I'm always starting with this one, because that's one of the most common mistakes for this is kind of mixing and matching. We're going to be very consistent. We're going to start with our y coordinate. So we're going to have 6 subtract 2 divided by our x coordinate. So in this case, that will be 4 because I'm keeping this coordinate as always being my first one, subtract 12. Now I know you're probably looking at this and going, it's not going to turn out as a nice fraction. Agreed, but at least I'm going to get the right answer. So we're then going to do 6 take away 2, which gives 4, and that is divided by 4 minus 12, which is -8. Okay, and if we simplify out this fraction, we're going to end up with -1/2. So our gradient is -1/2. Now, looking at this at the line that we've drawn on here, it makes sense. It's going, the slope is going downwards, so we have a negative gradient. It fits with the information that we've already got. Good start. Okay. If you have done this differently, if you have used this coordinate as your starting coordinate and this one as your second one, you will still have got the same answer. It doesn't matter which way around you use those coordinates. Similarly, if you've drawn a triangle on here and done it in a slightly different, looked at the increase and the decrease, that's absolutely fine. It works. It should give you the same gradient as -1/2. Now we can go back to our trusty y equals mx plus c equation and do exactly the same as we did before. We've now got all the information. Again, it doesn't matter which one of these coordinates we use to substitute in. You only actually need one. You need 2 coordinates to find the gradient, which is why you've been given 2 points to find the gradient. But for the rest of the equation, you actually only need 1 point. So I'm just going to, again, take the one that I've circled just because I've already circled it. Okay, so we've got a y value of 6, and that is equal to -1/2 times by our x value, which is 4, and then add c. Okay, so we've got 6 is equal to -1/2 times 4, which is going to equal -2. So remember, you have got a calculator. So if this is something that you feel like you're going to struggle with or you might make a mistake on, definitely use your calculator. It's a paper 2, you're allowed to use a calculator. Don't be afraid to use it for what might be considered an easy sum, because you absolutely don't want to make a silly mistake on this. You want to get it right, so you use your calculator if you need to. We can then pop some method lines in if that's how you choose to do this. We've got a -2 on this side. We want to find out what C is. So to find out, to get C on its own, we need to add 2 to both sides. And if we do that, we end up with C is equal to 8. So we're putting that all together. We can now write down the equation of line 1. So we've got y is equal to -1/2x plus 8. Okay, so this has got you a large chunk of the marks at this point. We found out the equation of both of the lines. Great, but it doesn't tell us the coordinates of point P. This is the second step, which I think is definitely a bit of a jump, and I can understand why this is the point that people are going to struggle with. So looking at this, if we've got two lines and they intersect at point P, the best way of doing this is to use simultaneous equations. So again, you're probably thinking, I had no idea, where did I get the jump that we needed to use simultaneous equations? So we need to remember that when two lines cross, they have the same value of x and the same value of y. To work that out, see, sometimes you might be given two simultaneous equations with a graph, and you know that the answer, the solution to those simultaneous equations is the coordinate where they cross. This is the opposite way around. We've been told they cross at this point. We haven't been given the coordinates. We've got to perform or use simultaneous equations to work out what this point is. So kind of going backwards from what you might be used to. So again, we're going to take both of these equations. We've got the y values on this side. They are both already equal, so I'm just going to use that to my advantage. In order to make this nice and simple for myself, I'm just going to say, okay, fine, set the y values equal to each other, and I can say that minus 3x is therefore equal to minus a half x plus 8. Now, I don't know about you, but this fraction gradient, or this fraction of x, is bothering me a little bit. So what I'm actually going to do is times everything by 2, and that's therefore going to just make it a little bit easier for me down this side. So I'll write a quick note to myself, that's what I've done, so that when I come back to it, I don't think, why did I do that? How did I get this? So I'm going to times everything by 2, so I'm going to minus 6x is equal to negative 1x, which is x, plus 16. Remember, when I've said that I'm going to times it by x, I can't just times this portion of it by x. I have to times the whole, times it by 2. I have to times the whole equation by 2. Next step then, this should be a straightforward solve for x now. So we've got negative x on this side, so I'm going to add x to both sides. Remember, negative numbers, if we're at negative 6 and we're adding an x, that means we're getting closer to 0. We're going in the positive direction. So we're going to end up with minus 5x. Again, if you're not sure, use a calculator. Is equal to 16. And then we want to divide by negative 5. No, that one, that one. Divide by negative 5. A little bit clearer on that side, to leave us with just the x value on its own. So we then end up with negative 16 over 5. Okay, if you would feel more comfortable, we can write this as negative 3.2. It's exactly the same answer, same number. Obviously, you can use your calculator, you put it into your calculator to work out that we've got negative 3.2. This is our x value. Okay. Equally, obviously, if you're happy leaving it as a fraction, leave it as a fraction. Both of these will get either marks. You're allowed to give either value. We've also got to find the y value. So our y value, I'm going to go back to line 2 because that's the simplest. I don't have to halve it when it's already a fraction. I don't have to deal with too many negatives. So I'm going to go back to this equation here. So I've then got y is equal to negative 3 times by negative 16 over 5. I mean, we've still got not nice numbers, but at least they're ever so slightly better than this combination here. So now we've got a negative times a negative, which is positive. We've got 3 times 16 over 5. So I'm going to do 3 times 16, which is 48 over 5. Now, again, obviously, you can leave it as this, or you can write it as a decimal instead. If you'd rather write it as a decimal, then it's 9.6. Positive 9.6. Again, so we don't need the positive, but when you've got negatives and positives, sometimes it does make it a little bit easier just to keep on track of what's going on. So we now have our x value and our y value. Remember, this is asking us specifically to find the coordinates. And on the mark scheme, if you just have x equals this and y equals this written down on your page, you do not get the marks. You need the final mark. You need to write down it as a coordinate. So if we're going to do that, x comes first, remember, we're getting minus 16 over 5, 48 over 5 will be our final coordinate. Obviously, if you don't particularly like fractions and you want to write it as negative 3.2, 9.6, that's absolutely fine as well. You would get the marks for this. This is our final answer here. So we started, just as a very quick recap what we've done there. We have used the gradient and the point that it passes, the line 2 passes through, to find the equation of line 2. We've then, similar process, we found the gradient and the y-intercept to find the equation of line 1. And we've then used simultaneous equations, making the y values equal to each other to find the point of intersection, which is point P. And these are the coordinates down here of point P. Okay, definitely a very tricky question. There's a lot going on. Hopefully you followed everything that I did. Don't be afraid to if you need to watch the video back again, just to kind of clarify what I've done at each step. Hopefully, even if you're really struggling with this, you'd be able to find the equations of both of the lines, even if that last step was just a jump too far for you. That's still going to pick you up definitely a few marks for this question. Okay, I'm going to leave it there for now. Thank you very much for watching, and please like and subscribe to the channel for more videos.